Right now, deep beneath the surface of the tropical Pacific Ocean, a massive pulse of heat known as a Kelvin wave is rising toward the surface, and forecasters are describing what happens when it gets there using language usually reserved for far more dramatic events. Meteorologists at Severe Weather Europe have labeled the moment an atmospheric code red, saying this subsurface heat pulse is acting like a release valve that is about to kickstart a full reorganization of global weather patterns, starting in the tropics and rippling outward from there. The latest ensemble model runs from the European Centre for Medium-Range Weather Forecasts, NOAA, and Australia's Bureau of Meteorology now align on a genuinely historic trajectory, with several forecasts suggesting this event could become the strongest El Niño ever recorded, potentially surpassing even the extreme event of 1877 and 78. Here's what actually has forecasters uneasy about all of this, and it is not simply that El Niño is strong. A study published in December of last year found that the strongest El Niño events do not just gradually raise temperatures and shift rainfall patterns the way weaker events tend to. They can trigger sudden climate regime shifts, abrupt reorganizations of temperature and precipitation patterns, rather than smooth, predictable transitions. And that same research found this effect appears to be intensifying in a warming world. This is the story of what that sudden shift actually looks like, why the current event is tracking toward genuinely uncharted territory, and what, scientists say, comes next. No hype, no exaggeration, just what the data from the World Meteorological Organization, NOAA, and the researchers actually tracking this event are saying. If you have felt this year's extreme heat or unusual weather firsthand, drop a comment and tell me where you are watching from. I read every one of these. If you want grounded science coverage instead of panic headlines, subscribe. It is free, and a like helps this reach people before the shift actually arrives. Let us go for 5,000 likes on this one. Thank you. Now let us get into it. To understand why this particular El Niño has forecasters using words like code red, you need a quick sense of what El Niño actually is. It is the warm phase of a recurring cycle in the equatorial Pacific Ocean called the El Niño. Southern oscillation, alternating every few years between warm El Niño phases, cool La Niña phases, and neutral conditions in between. During a strong event, unusually warm water spreads across the central and eastern Pacific, disrupting a massive loop of rising and sinking air called the Walker circulation, and that disruption acts like a bridge carrying the Pacific's warmth into weather patterns across the entire planet, altering everything from monsoon timing in South Asia to storm tracks over North America, and rainfall patterns across parts of Africa and South America. The World Meteorological Organization's most recent update found more than an 80% likelihood of El Niño conditions continuing through the middle of this year, with probabilities of it persisting into November, running near or above 90%, and multi-model forecasts showing sea surface temperature anomalies expected to exceed 2 degrees Celsius in the Pacific's key monitoring regions, comfortably past the threshold that defines a genuinely strong event. The numbers behind this year's event are worth stating plainly because they explain exactly why researchers keep reaching for historical comparisons rather than simply calling this an ordinary strong El Niño. The strongest El Niño on record prior to this one saw water temperatures reach 2.5 degrees above average during the fall and winter of 1982 and 80 winter of 2015 into 2016, reached 2.4 degrees above average. Ensemble forecasts made on July, the first of this year by the European Centre for Medium Range. Weather forecasts are now showing this event potentially pushing past 3 degrees above average, a level that would place it beyond every event in the modern instrumental record. Other forecasting centers are more conservative, projecting a strong or super event without necessarily guaranteeing a new record, but the overall direction every major model agrees on is the same, an event still actively intensifying rather than leveling off. It is worth noting that forecasters have flagged genuine uncertainty around the exact peak strength this event will ultimately reach, a limitation tied to what researchers call the spring predictability barrier, a well-known seasonal gap in forecasting confidence that tends to ease as the year progresses and more direct observations become available, meaning the picture should sharpen considerably over the coming weeks, rather than staying this uncertain through the rest of the year. This is where the December study becomes genuinely important to understand, because it explains why forecasters are uneasy about something beyond simply how warm the ocean gets. Researchers found that the very strongest El Niño events are capable of driving what they termed sudden climate regime shifts, meaning temperature and precipitation patterns across large parts of the planet do not simply drift gradually into a new state as the ocean warms. Instead, once conditions cross a certain threshold, the atmosphere can reorganize abruptly, flipping regional weather patterns into a meaningfully different configuration within a comparatively short window rather than easing into it over months. The same research found evidence that this tendency toward abrupt reorganization appears to be growing more pronounced as the broader climate continues warming, meaning the same intensity of El Niño event may now be more capable of triggering this kind of sudden shift than an equally strong event would have been decades earlier. That distinction matters enormously for anyone trying to plan around a seasonal forecast, since a gradual transition gives communities, farmers, and infrastructure managers time to adjust incrementally, while an abrupt regime shift compresses that same adjustment into a much narrower window, leaving considerably less room for course correction once the shift is already underway. WMO Secretary General Celeste Saulo has been direct about what forecasters expect this specific shift to bring, stating plainly that this event will intensify the risk of heat waves, on land and marine heat waves across many regions of the world. The July through September outlook the WMO issued alongside that statement projects a nearly universal dominance of above normal land temperatures across nearly the entire globe, with the signal running especially strong across southern North America, Central America, the Caribbean, Europe, and northern Africa, alongside more than an 80% likelihood of above normal sea surface temperatures across the equatorial Pacific east of the international dateline. Above normal ocean temperatures are also expected across the Indian Ocean and the tropical Atlantic, while a horseshoe-shaped band of below to near normal temperatures is forecast across parts of the North Atlantic. A genuinely global footprint for a single ocean pattern originating in one specific stretch of the Pacific. Marine heat waves specifically deserve attention, beyond their effect on air temperature, since sustained warming of ocean water at this scale has historically been linked to coral bleaching events, disrupted fish migration patterns, and stress on marine ecosystems that can take years to recover even after the underlying El Niño event itself has fully faded. The practical weather consequences of this shift are already showing up in seasonal outlooks across multiple continents. During Northern Hemisphere summer, El Niño's warm water tends to fuel hurricane development in the central and eastern Pacific while actively suppressing it across the Atlantic basin, a pattern already reflected in this year's quieter than average Atlantic hurricane outlook, even as forecasters caution that a suppressed season has never guaranteed a landfall-free one in comparable historical years. Forecasters at Severe Weather Europe have pointed to a shifting jet stream over both North America and Europe as one of the first atmospheric impacts expected as this event continues strengthening through summer and into fall, with the broader pattern. Reorganization expected to intensify further, as El Niño's influence typically peaks during the Northern Hemisphere winter months, rather than during summer itself. Historically, strong El Niño events have also been associated with a genuinely wide range of extreme outcomes depending on region, including massive flooding in some areas, severe drought in others, and significantly altered storm tracks capable of reshaping an entire season's weather rather than producing a single, isolated event. Agricultural regions dependent on predictable monsoon timing, water managers planning reservoir levels around historical rainfall patterns, and coastal communities monitoring hurricane risk are all among the groups forecasters say stand to be most directly affected if this event's regional impacts do arrive as abruptly as the underlying research suggests they could. There is a genuinely important distinction worth holding on to here, one that separates legitimate scientific concern from unnecessary alarm. Every El Niño event behaves somewhat differently, the same way every hurricane carries its own individual quirks, despite sharing an underlying storm type. And forecasters have been careful to note that El Niño is only one influence on global weather among several, rather than the sole determining factor. What makes this particular event worth the elevated attention it is receiving is the unusual combination of factors converging at once. A subsurface heat reservoir large enough to be compared to a release valve, model agreements strong enough to point toward genuinely record territory, and new research suggesting the strongest events specifically carry a heightened risk of abrupt, rather than gradual, pattern shifts. None of that guarantees a specific catastrophic outcome for any single region. It does mean the standard assumption that a strong El Niño simply nudges weather patterns gradually in a known direction may not fully apply this time, which is precisely the source of the genuine unease researchers have been describing, and precisely why so many separate forecasting centers, rather than a single outlier model, are converging on language this direct. So what does all of this actually mean for you, wherever you happen to be watching this from? It does not mean every extreme weather event for the rest of this year will trace back directly to El Niño, and treating every heat wave or storm as automatically explained by this single pattern would oversimplify a genuinely complex system shaped by many overlapping factors at once. What it does mean is that the second half of this year carries a meaningfully elevated chance of your regional weather shifting into a new pattern more abruptly than past experience with weaker El Niño events might lead you to expect. The practical takeaway is to pay real attention to seasonal outlooks as they update through the rest of the summer and into fall, rather than assuming the current pattern, whatever it happens to be where you live, will simply continue in a straight line. If, You work in a field genuinely sensitive to seasonal weather, agriculture, water resource management, insurance, or emergency planning among them. This is a reasonable moment to revisit contingency plans built around a typical or moderate El Niño year, since the research described throughout this video suggests this event may not behave typically at all. The honest, grounded summary of this story is this. A historically powerful El Niño event is actively strengthening in the tropical Pacific, with the latest model ensembles suggesting it could become the strongest ever recorded, driven by a massive subsurface heat pulse forecasters have described as an atmospheric release valve, currently rising toward the surface and expected to accelerate the pattern shift already underway through the rest of summer. Research published late last year found that the strongest El Niño events specifically carry a heightened risk of triggering sudden climate regime shifts, abrupt reorganizations of temperature and rainfall patterns rather than gradual transitions, and that this tendency appears to be intensifying in a warming world, a genuinely different kind of risk than simply expecting a hotter, wetter, or drier season along familiar historical lines. The World Meteorological Organization already projects a near universal dominance of above normal temperatures worldwide through the rest of this year, alongside a genuinely wide range of possible regional extremes, from flooding to drought to significantly reshaped storm tracks, as this event continues strengthening toward what may be uncharted territory in the modern climate record, with forecasters expecting the clearest picture of its ultimate peak strength to emerge only as the spring predictability barrier eases over the coming weeks. We are going to keep tracking this event as it develops, sourced the same way we did. Today, straight from the World Meteorological Organization, NOAA, and the researchers actually studying how these regime shifts unfold, not recycled headlines dressed up as breaking news. Subscribe so you do not miss it if this event does push past the historical record, because based on where the models currently stand, that update may not be far off. And leave that comment below. Tell me whether your regional weather already feels different this year, and whether you had heard about this event's record potential before today. Because behind every one of these ocean temperature charts is a farmer somewhere watching a rainy season that no longer matches the one their parents planned around, a forecaster staring at a subsurface heat pulse large enough to be called a release valve, and an entire planet's weather quietly reorganizing itself around a single, unusually warm stretch of the Pacific Ocean that most people will never see directly, but every one of us will eventually feel the effects of in some form. 5,000 likes on this one. Let us go. See you in the next one.